guys, so welcome back to another video, and we're going to be doing computing the area of parametric curves. And I'm going to explain first of all how we're going to do that, and then we're going to do a few examples. So when we compute an area, let's imagine that we had a y equals fx graph. We don't have that, but let's pretend we do. We want to compute the area of this graph, we just simply do the integration from a to b of y dx, right? Well, this is the same kind of thing. We have x equals ft and y equals gt. And all we have to do is sub stuff back in here, which equals this. So for example, for dx, we can just differentiate this equation, dx equals f dash t dt. And then we can just put this where dx was. We can put gt where y was, if you look down here, gt where y was, f dash t dt. And honestly, a confusing thing is just the limits. So we're doing it from when x equals to a to when x equals to b. But when we do it with a parametric curve, we're going to be doing it in relation to t. So when x equals to a, we need to find what that t is. So we do x equals to a equals ft, and then we solve for what t is, and we get t equals alpha. Then for when x equals to b, which equals to ft, we solve to get beta, and then that's all we do, from alpha to beta. So let's do an example. Where's my pen? It's right here. So let's do an example. Let's do this one. See if I can copy this. Okay. Oops. Sorry, guys. Copy. Okay. So let's say that we had an example here of an ellipse with the formula where we have x equals this, x equals a cos t, and y equals b sine t. So again, if we were to want to find the area of this ellipse, we're going to have to do it from a, or technically this is minus a. This, we're going to have to do it from minus a to a of y dx. Well, then we have it in here. So let's find it. First of all, what's dx? Dx is equal to the differentiation of this. It's going to be minus a sine t dt. And so our new equation might be minus a to a of y. So y equals b sine t. So we'll put b sine t in here, multiplied by dx, which is simply minus a sine t dt. Okay, and then we can just get minus a and b out, so it's minus ab, and then we just have sine squared dt, right? Okay, now we need to find the limits. So when x is equal to minus a, right, that means ft, whichever it is, so a cos t is also equal to minus a. Okay, so let's divide by a. Minus 1 equals cos t. Okay, so for minus 1 to be equal to cos t, we have, if you remember the cos graph, minus 1 is here, which is pi. So t has to be equal to pi, right? So the minus a limit turns into pi. And then when x is equal to a cos t is equal to a, and so we divide by a, that's 1 equals cos t. And so there's two situations for this within the limit of this question. So when the cos graph is here, we're looking at 2 points. This one and this one, that's going to be 0 and 2 pi. So we can have t equals to 0 or t equals to 2 pi. Now this is where it gets tricky. If you look at this graph, technically this graph is not a function, right? Parametric curves aren't a function because they've often failed the vertical line test. So actually, if you think about it, from 0, so we have a limit, right? We can either do this as pi to 0 or pi to 2 pi. So let's imagine that pi to 0 would give us this one, and pi to 2 pi would give us this one. So we can see how we have to choose one of the limits, and that will give us half of the equation, or half of the area. And then because if we take the red area, then this is this. Or if we take the green area, it'll be this. Whichever the area is, we're going to have to multiply by 2. So I'm just going to choose, let's take 0. So we take pi. So let's rewrite this equation. It's going to be pi to 0. We choose the 0 one. Let's pretend that's the top one. We have ab and sine squared t dt. Okay, and let's say that I don't want pi to 0. I want 0 to pi. That's going to be ab and we take the minus, we put it into the limits. We're going from the opposite direction, from 0 to pi. That's where the minus went. Sine squared t dt. And remember, this is only half of the area. We have to multiply by 2. So let's have 2ab 0 to pi sine squared t dt. Okay, now we can use the double angle identity. Cos 2 theta equals 1 minus 2 sine squared theta. So sine squared theta, I never am able to do this. Minus 1 sine squared theta is therefore 1 minus cos 2 theta over 2. Okay, so now our integration turns into something like this. Let's split this prematurely. Like that. Okay, and now this is as simple as doing this. 1/2 t minus cos 2t. Cos 2t because it was sine t, yep, cos 2t. This integrates into minus 1/4 sine, let's redo this, minus 1/4 sine 2t from 0 to pi. Is that true? So 2 comes out to 1/2, sine turns into normal cos, yep, okay. So now all we have to do is 2ab, so 1/2 pi, so pi over 2, minus sine of 2 pi 0, and then we minus everything, so we minus 1/2 0, 0, okay, minus 1/4 sine of 0 is 0. So it's just this, which is going to give us pi AB. And I'm going to check my answers really quick. It is pi AB. So yeah, that's how you found the area. Remember, the tricky things are with the limits and realizing that it's like a half. Okay, let's move on with the next example. Okay, so this is a really famous example. It's called a cycloid, right? Where it's like you have a point on a wheel, it has radius r, and then you roll it and you track this point. This is what you get. And it was famous because Galileo guessed that the area underneath one of these arches is equal to something multiplied by pi r squared, but he doesn't know what constant it is. So let's try to do it. We will do, so you can imagine the situation. I'm going to copy the equations over. And, oh, and just to keep in mind, each arch has a length here of 2 pi r. That's the circumference of a circle. Okay, so we have these equations here. We want to find the area, so that's going to be from 0 to 2 pi r of y dx, right? 0 to 2 pi r, and this is in terms of y, and this is in terms of x. Okay, so first of all, we need to find dx. So dx is equal to differentiation of this. Let's multiply everything inside just to make it clearer. So t, so r multiplied by t, multiplied by minus r sine t. Okay. So this would simply be t into 1, so that's just r. R is a constant. Minus sine into cos, so it's r cos t. And this would simply be r multiplied by 1 minus cos t. Okay. Y, so let's rewrite this equation without the new limits yet. So 2 pi r, or let's just say alpha and beta. Y is r 1 minus cos t multiplied by r 1 minus cos t. Okay, cos t dt. I forgot about that. Okay, so now we need to find the limits. The limits when x. Okay, so let's do the limits here. When x is equal to, what's the bottom limit first? Let's do from 0. X equals 0. So r t minus sine t is equal to 0. So that means you can divide by r. So that's just t minus sine t is equal to 0. So therefore sine t is equal to t. So the only situation that this would happen with is when t equals 0, right? Because if t equals 0, sine 0 is equal to 0, so therefore 0 equals 0. So the only situation where this is true is when t is equal to 0. Next, when x is equal to 2 pi r, r is equal to t minus sine t. Okay, so you can cancel the r's out. So it's 2 pi is equal to t minus sine t. So sine t plus 2 pi is equal to t. Okay, the only situation where this would happen is when t equals to 2 pi. Because if t equals to 2 pi, Sine 2 will be equal to 0 because sine 2 pi is equal to 0, and t is equal to 2 pi, so 2 pi equals 2 pi. So the only situation where this is true is when t equals 2 pi. So now that we have the new limits, we're going to redo the equation with the new limit. So the top limit was 2 pi, is 2 pi now, and this is 0. And let's take the r out, so this is r squared on the outside. And now we have 1 minus cos t all squared dt. Okay, let's expand this. So this is going to be 1 minus 2 cos squared t plus cos squared t. Yeah, plus cos squared t. So 1 minus, no, sorry. 1 minus 2 cos t plus cos squared t. We can take cos squared t into using this. 2 cos theta minus 1. So cos theta would be equal to cos 2 theta plus 1 over 2. Yes. So this we can rewrite as 1 minus 2 cos t. Let's split it up. So plus cos 2 theta over 2 plus 1 over 2. Okay. And now that's just the integration of this from 0 to 2 pi. R squared. Okay. So now r squared, 1 integrates into t minus 2 cos t. That's just 2 sine t, because sine differentiates it into t, plus cos 2 theta, that's 1/4 sine 2t, sorry. Yep, this turns into 1/2 cos 2t, yep, plus 1/2 t from 0 to 2 pi. Okay, and then this would simply be r squared multiplied by 2 pi. Sine 2 pi is 0, plus 1/4 sine 4 pi is also 0, plus 1/2 t. So that's plus pi. And then we're going to minus 0, sine 0, sine 0, 0. Okay. So what we end up with is 3 pi r squared, which is the answer. So yeah, Galileo guessed that it was just a constant multiplied by r squared. He's really close. It's just 3 pi r squared. Really interesting. I don't know why that is. Okay. That's it for the area examples. I'm going to do arc length now, so stay tuned for the next video. Thank you guys so much.